हिसाब से बिल्कुल हूबहू मैचिंग बहुत ही मुश्किल है। इस चीज़ का आप ध्यान रखेंगे और जो भी डेट है उस पर आप सबमिट करें। ओके, सो yesterday in last class basically we had studied some methods about that is your steepest descent method. Okay, so today we will try to explore one more question, and that is based on that steepest descent method. And basically if there is a simple numerical, then no problem, you can find your what are the value of alpha for your function ff by differentiating and then equating to zero, and then try to find the double derivative, and then that is positive. This means so alpha has minimum value for that function ff. Okay, but if your function is some complicated form, then generally we solve by this ordinary calculation. Okay, so in that case we will solve our problem by using some software. Okay, so here in examination you can solve that problem by using simple calculation, but in general you if you have any software like MATLAB or Mathematica, okay, or Scilab or Python, okay, so you will do that problem by using that software for evaluating simple the minimum value of alpha. Okay, so now today we will discuss one problem that is based on this method, and then to go to next method, that is Newton's method, and that is quite better than that method of this Newton's method. Okay. So now we'll start our lecture. So now in steepest this method, I am taking a problem that is okay. So we use the method of steepest descent and to find the minimizer of any function. Okay, so we use the method of steepest descent with descent to find minimizer of function, and that function is suppose that function is suppose x1, x2, x3, suppose x4, and that function that equals to x1 minus 4 to the power 4 plus x2 minus 3 square plus 4 times x3 plus 5 to the power 4. Okay, suppose this is your function. Okay, and this is if we take only not x1, x2, x3, 4, but we take only 3 variables here. Okay, so now we take this only 3 variables. Okay, either we take here some x4 minus 3 to the power 3. Okay, or we take only 3 function. So this is your function fx that equals to fx. Okay, so this x belongs to R3. Okay, so you have to find the minimizer by using the steepest descent method. Okay, so now in this case we select an initial point. Okay, so here you see that this first term is your even power of x1 equals to okay, so this is always any value of x1 is lies on real R. So this is here this x2 is opposed this power of 2, so this is again a positive number, and here x3 to the power 4, this means this is again whatever the value of x3 then x3 plus 5 to the power 4 is always positive number. Okay, so this is the sum of the positive numbers. So this means you understand that is what is the local minimizer of that point. Okay, so if this point is, suppose that this point is 0, this point is 0, this point is 0, this means x1 equals to 4, x2 equals to 3, and x3 equals to minus 5. So this value is you can roughly calculate it. This is your the local minimizer of that function. Okay, so now here we choose the initial point, which is which initial vector, that is x, that component are x1, x2, x3. This is approximate equals to the local minimizer. If you are able to find out what is your local minimizer, then you try to proceed with initial choice with a very approximate value of that. Otherwise, you are free. You are starting with your origin, that is x1 equals to 0, x2 equals to 0, and x3 equals to 0, and go ahead and then you can find your solution. Or you can take any value of, suppose x1 is 1 and x2 is 0 and x3 is 0. Or any student we start with 1 1 1, x1 is 1, x2 is 1. Okay, so because we take initial point, that is a very simple point. So either we change the take the value is origin, or any x-axis, x1 axis, x2 axis, or x3 axis, or in general 1 1 1. Okay, so you are free to choose any initial choice. Okay, but in this problem, you are, if you checking that, this means x1 is 4, x2 is 3, and x3 is equals to minus 5. So you can also choose that point. This is approximate neighborhood of this point. Okay, so here we choose the initial point. So the sorry. So the initial point that is, we take x0 and has component are x1 0, x2 0, and x3 0. And if we take this point is equals to, suppose if we taking first one is 4, that's equals to 0, and second one is approx equals to this thing, and third one is, suppose we take minus 1. Okay, so we don't know what is the minimum value of that function. Okay, so that's why we take any value. Okay, or you can choose 0 0 0, or you can 1 1 1, or 1 0 0, or 1 0 1, or 0 0 1. Okay, in any one. Okay, so now we perform here because you know that if the number of iterations are increases, then your result is approaches to the exact solution. Okay, so this means if the iterations are, suppose 5 6 7 8 10. Okay, so then this the result from this 10th iteration, this is the final one of corresponding to your 9th, 8th, or 6th, or 4th. Okay, so this means here we do only some steps here for your consideration. Okay, so that's why we only solve only 2 or 3 iterations here, and at similar process you will do for the next 4th iteration, 5th iteration, or whatever say in the your problem. If your problem say you do this, if with 5 iteration find the result at the 5th iteration, or this is the what are the exact solution for this problem, and try to approximate that solution by using steepest descent method in 6th iteration. So so in that case you are free to find that number of iterations. Okay, so here we perform only here 2 or 3 iterations. So here we perform here, suppose if we take 3 iterations, and I think in 3 iterations you will have some idea how to solve that type of problem. Okay, so if we take 3 iterations, so now first of all we find the gradient of your given function, that is fx. Okay, so here the gradient is, this means if we have to differentiate this function partially with respect to x1, with respect to x2, and with respect to x3. This, if we differentiate with respect to x1, this is 4 of x1 minus 4 to the power 3, and with respect to x2, this becomes 2, x2 minus 3, and if we differentiate with respect to x3, this becomes 16, x3 plus 5 to the power 3. Okay. So, so suppose this is your gradient of fx. Okay. So now you have to find what is the gradient of this at point initial choice. Okay. So now the gradient of f at x0. We have to find what is the value of gradient at x0. So now we have putting here x1 equals to 4 here. So this means this value is 4 minus 4 cube, and second one is 2. What is the value of x2 is 2 minus 3. Okay, and x16, x3 value is minus 1 plus 5 to the power 3, that is transpose. Okay, so if you're solving that, that first term is 0, second term is minus 2, and third term is 4 to the power 3, and we have 4 square, 4 to the power 5. So the 4 means 1024. Okay, so this is your first gradient of that. Okay, if this gradient of that equals to 0, if suppose if you find that value equals to 0, this means this is your local minimizer. X point is your minimizer. Okay, so suppose any student take this point, suppose 4, 3, and minus 5. So for that, 4, 3, minus 5, this gradient is 0. So that's why this x naught is there. Okay, so now you have to find what is the value of x naught minus alpha gradient of this f of x naught. Okay. So you have to find that value. If alpha is remain constant, if alpha is suppose fixed 1, suppose alpha equals to 1 in all iterations, that method is belongs to gradient method. But here this alpha is changed because we know we have to solve this steepest descent method. Okay. So now what is the value of this function? So x naught at this point is 4 minus of alpha of that. Okay, so this means if we try to solve this point, so this becomes first point x naught minus alpha times, and this fx naught component is 0. So this means this is your first component. Second component is 0, 2 minus alpha and minus 2. So this means minus minus plus. So this means plus 2 alpha. And third term is minus 1. And here this is minus of alpha times this thing. So minus of 1024 alpha. So this is the value of x0 minus this thing. Okay. So now we have to compute what is the value of x1, first iteration. So to compute x1, so we need this alpha 0, that is equals to argument of that alpha, which is the greater or equals to 0, for which our function has minimum value, and that function is f of x0 minus alpha at that point, and that point is alpha gradient f of x0. Okay, so now this equals to argument of alpha, that is greater or equals to 0, and here the minimum value of that. Okay, so this means your minimum value of function, and that function is here f at this point, and your function is defined by this formula, and this point is what is the value of this x naught minus this value is 4 minus, okay, this is simply 4, this is 2 plus 2 alpha, and this is, so now putting in this equation. Okay, so this equals to minimum of, this is 4 minus 4 to the power 4 plus 2 plus 2 alpha minus 3 square plus 4 times x3 value is minus 1 minus 1024 alpha plus 5 to the power 4. You have to find out this function value, this function of alpha, and you have to find that at what value of alpha this value is minimum. Okay, so if this equation is suppose a normal equation, then in that case you can solve this by differentiating that function f alpha, and then you find out that alpha solution. Okay, but here this alpha is a fourth order. This is a fourth order, and then you differentiating that this is of third order, okay, or in higher cases, suppose this is of suppose 10, okay. In that case, you can solve this by a software and try to find the local minimizer. Okay, so if we draw this function, if we draw this function with if this is your function of alpha, okay, so, and this is so for this alpha 0, if we try to denote that function is phi 0 alpha, and if we draw this with in MATLAB, okay, so here with this function, if we draw in MATLAB, so suppose this is a 0.002, okay, and suppose this is 0.003, this is 0.004, 0.005, 0.006, and 0.008, and here there are some values here. Suppose here this value is 1000, this is 2000, this is 3000. Okay, if we are trying to plot this with MATLAB, and this is a function value of this is your this direction is your alpha, and this is your function value phi 0 alpha. Okay, so if we try to plot this graph into the MATLAB, okay, so in this case you find what is the minimum value of alpha, and that minimum value of alpha is approx. The curve is aligned in this way. Okay, so if we plotting that curve, so this curve is moving through this manner. Okay, so here at this thing. Okay, so now here this minimum point, and this minimum point is approx. That minimum point is your alpha, and here the alpha value is here. Alpha is to find out this is a 3.97 96, if you try to 3 decimal places into 10 to the power minus 3. So at this value, you see that the alpha is minimum. Okay, so this is a graph of phi 0 alpha with versus your alpha. Okay, so if we draw this in MATLAB, so you find that what is the minimum value of that. Okay, so in that case, your alpha 0 equals to 3.967 into 10 to the power minus 3. Okay, so either you solve this by manually, or you can solve by this is using a software. Okay, so then if you are able to find this alpha 0 value, okay, so here now then your x1 value. So what is your x1 value? So your x1, that x1 value that equals to x0 minus alpha 0. This is gradient of f at x0. Okay, so now here if we try to find this value, this is x0 is 4.000, and if we putting this alpha 0 here and then multiplying by this gradient of fx naught here, then this point is, if we directly write this after calculation, this is 2.00008, and this is minus 5.062. Okay, so this is your next point, that is your x1. Okay, so now if we are able to find this x1 point, then we have to find what is the gradient at that point. If gradient is equal to 0, this means this x1 is your local minimizer. Okay, so this implies what is the value of gradient of this point. Okay, so now what is the gradient of fx? So this is your formula. So now you are putting simply x1 value here, x2 value here, and x3 value here. So if gradient of that, after putting, we get directly this equals to 0.000. Okay, and here minus 1.984, and this point is minus 0.003875 transpose. Okay, and that is not equal to 0. This means this action point is your not local minimizer. Then we have to go to compute this x2 point, and for x2 point we need alpha 1. Okay, so for this point we have to find what is the value of x1 minus alpha, and that the gradient of fx1. Okay, so now next page, So next we find alpha 1. We find alpha 1 where this alpha 1 that equals to augment of alpha, that is beta equals to 0, beta equals to 0, and the minimum of this function, and that function is the value is 0.0 plus 2.008 plus 1.984 alpha minus 3 square plus 4 minus 5.062 plus 0.003875 plus 5. Okay, so simply do this by using our formula and values to distinct your values. Okay, and this is your augment of alpha beta equals to 0, and suppose this function is your phi 1 alpha. Okay, phi 1 alpha. Okay, so now if we using this phi 1 alpha and try to find what is the value of phi 1 alpha, so if we draw this in MATLAB, so our MATLAB figure is just like as here. This is point 1, here point 2, point 3, point 4, point 5, point 6, okay, point 7, point 8, and here point 2, point 4, point 6, point 8. Okay, and now if we draw this function, that is phi 1 alpha with alpha, and this is your alpha, and here this is your phi 1 alpha, and this is your graph of phi 1 alpha versus alpha. Okay, so now if we draw this, so this function is like this type of behavior. This is like that, okay, like that. Okay. So here this is this value at this point is your local. This is the minimum of this function. This is your phi 1 alpha, and this is your alpha. Okay. So now for what value is here? Okay. So this value equals to phi 1. That value is equals to, so this equals to here phi 1, that equals to we find that value is 0.500. Okay, and this is from MATLAB figure. Okay, so you can find easily what is the value of alpha 1. So now we have to find this next value, that is x2. So this x2 equals to, our formula is x1 minus this alpha 1 and gradient at the functional value at fx1. Okay, so now here you have this value and alpha 1. Okay, so if we putting that value and solve that, that value equals to this 4.000 and here 3.000, and this value is minus 5.060 transpose. Okay, so now you have to find this value at what is the gradient at that value. Okay, so now this gradient at x2. So if we putting that value x2 in your gradient function, so this equals to, this is 0.000, second one is 0.000, and third is 0.003525. Okay, this transpose. This means this is not equals to 0. This is approximate equals to 0. Okay, so that's why this x2 is not your local, that is minimizer. Okay, so in that case, now we find your next point, that is x3. So here we find x3. To find x3, so we approximate this x3 equals to, okay, so what is the value of alpha? Okay, so we have to find is to find x3, which is equals to x3 equals to x2 minus alpha 2 gradient at fx2. Okay, so we have to compute this alpha 2. Okay, so what is the value of alpha 2? So alpha 2 that equals to argument alpha is greater or equals to 0, and we have to find the minimum value on putting this value here. So this is your phi 2 alpha, and that function is 0.000. If you're putting that plus 0.000 plus 4, because first and second your point is 4 and 3, so that's why this becomes 0 and this becomes 0. Okay, and next one is 4 times value is minus 5.060. This is minus 5.060 plus this gradient is minus 0.00. This this point is minus 5.0 plus 0.003875. So this is 0.003. If we try to solve this 3525 alpha plus 5, this is 0.003525 alpha plus 5, and that transpose that to power 4. That power 4, this value of your phi, this function is phi 2 alpha. This is phi 2 alpha. Or we say that you have to find the value of alpha when the minimum value of our phi 2 alpha. Okay, so if we plot our graph, this is alpha and this is phi 2 alpha, and if we try to find our graph in this figure, okay, and if this point is suppose here something 12, here 14, here 16, here 18, here 20, and here suppose point 4, point 8, okay, so 1.2, 1.6, and if we try to plot this curve, so this curve is looks like this goes at the point 16, and then like that. I think this graph is like that. This is goes to like that. Okay, and this point is of order 10 to the power minus 6 here. Okay, so this is that is we take xk, that current point, and we have to find the what is the next iteration point, that is xk plus 1. Okay, so now we have to neglecting, because this is a twice differential function, so that's why we're neglecting our third order and higher degrees term. Okay, so neglecting terms of order 3 and higher. Okay, so now we obtain by using simple Taylor's expansion, we obtain here, if we write fx for general fx, and here in the sense of that x means next iterations, that is xk plus 1. So what is the value of that x? Okay, so here you can also write this x can be written as this function value at xk plus x minus xk. Okay, so now this xk adding here and minus xk adding here, this means if we write this fx, this equals to, this is approximate, that value is approximate, you can say this at point xk, and here plus x minus xk, and this is the first order this is gradient of that. Okay, so this means we write here this is gradient of f at xk, and then 1 by 2 is x minus xk transpose, and the second order means Hessian of at point xk, this is x minus xk, and then third order, and we neglecting that. Okay, so this means we neglect that, so this means this is approximate, that equals to this function, and this function, if we write that function is your qx. Okay, and here if we write this gradient of f, if we define that term is gx. Okay, this is q and this is gx. Okay, so now where for simplicity we write here for simplicity we use the notation, and that is a gradient of that. This means this is known as xk, and this is known as suppose gk. Okay, so we can write here this value at one xk, this is gk. So we note the notation this gk that equals to gradient at point xk. Okay, so that's why we using that. Okay, and if this Hessian is greater than 0, then you say that your this function q achieve a minimum. Okay, so if the Hessian at point xk, this is positive, then your q achieve a minimum at your point x. Okay, so here look here, if we try to find what is the value of x here. Okay, so for the minimum value, so this means this gradient at minimum value that equals to 0. Okay, so that's why you have only this point. Okay, so now at gradient point that equals to 0, this means you, if we what is the qx, so if we differentiating that, because this is achieve a minimum, so any function achieve minimum, that means if you're differentiating that point equals to 0, and that you have to find that value of x here. Okay, so if means if you're differentiating qx, and what is the value of qx here? Qx value equals to this f of xk. Okay, so now if you're differentiating, so this becomes the gradient of fxk, and gradient of fxk is equals to gk. Okay, and now plus plus, and here if we differentiating that term, so this equals to x minus xk, and here this derivative of that is second order derivative, and that is your Hessian, that is f of xk. Okay, so this means this time, and here because this is only second order continuous function, that's why we letting that down. Okay, so now you have this point, and this point equals to zero. This point equals to zero because the first order derivative equals to zero. This is your necessary condition. Okay, so now here this equals to zero. This means what is the value of gk here? Okay, so now this gk, that gk of minus sign, that equals to Hessian matrix at xk into x minus xk. And this Hessian matrix, if we because this is non-zero matrix, so if we multiply by inverse of that, this becomes minus of gk into inverse of that matrix, that is f inverse at xk. Okay, that point equals to x minus xk. X minus xk. What is the value of x here? What is the value of x here? So x equals to xk minus this f inverse at point xk into gk. Okay, so this is the value of x here. And what is the x? X is basically you're the next iteration point. So this means x is basically the next iteration. That is, you say that this is x plus k. This is the new next iteration. Okay, so now here we can write that value at your xk. At what value you attain minimum? That is your x, and that xk is next iteration of x. That's xk plus 1. That xk plus 1 is equals to xk minus Hessian matrix at value of xk inverse into gk. Okay, so this is your formula, that is your Newton's method. Okay, so in Newton's method, you have, this is your initial point, and then you have to find the gradient of that. This is your gk, gradient of that point. This is your gk. Okay, and now the Hessian matrix, and you have to find the inverse of that Hessian matrix. Okay, so if we take a example and try to solve this formula, and this is basically used as the recursive formula of Newton's method. Okay, so this recursive formula, this recursive formula represents Newton's method. Okay. So now we take example and try to solve that problem by using this Newton's method. Okay. तो अभी हमारे पास 12 minutes हैं, तो हम quickly solve कर लें. On next page, so use Newton's method to minimize the function and that function is x, x1, x2, x3, and x4. Okay, so if there are 4 variables, this means your Hessian matrix of order 4 cross 4. If this is only x1 and x2, then your Hessian matrix is of order 2 cross 2 matrix. Then for inverse matrix, this is simple for 2 cross 2 matrix or 3 cross 2, but in 4 cross 4 matrix, this is quite difficult. Okay, so then in that case, you opt any software. Okay. So here this function value that equals to x1 plus 10x2 square plus 5x3 minus x4 to the power 2 plus x2 minus x3 to the power 2 plus x2 minus 2 to the power 2 plus x3 to the power 2 plus x4 to the power 2 plus x4 to the power 2 plus x3 to the power 2 plus x4 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 to the 2x3 to the power 4 plus 10 x1 minus x4 to the power 4. Okay, so this is your function, and now you have to find out what is the minimum value, and here your starting point is given. So use as starting point that point is x0, and that starting point is suppose 3 minus 1 0 and 1. Okay, transpose, and you have to perform 3 iterations. Okay, in general we opt 3 iterations and try to solve. So here note that at our initial point we have to check that this point is minimum or not. So we have to find that what is the function value. So note that what is the function value at that point. Note that your function value at x naught. So if we putting x naught here, then this value is equals to, this is 3 plus here 10 into minus 1 square plus 5, this is 0 minus 1 square, and here minus 1, and here minus 2 into 0 to the power 4 and plus 10. Here we're putting simply x1, x2, x3 and x4 by using this x1, x2, x4 in this equation. Here 10, 3 minus 1 to the power 4. Okay, and on solving this equals to 215. So this is your function value at that point, and you have to check that the function value at next step is reduces or not. Okay, so that means you go in the right direction. So we have, what is the gradient? So if gradient is 0, that means this point is your minimum point. If fx naught, what is the value of fx? So if we first calculate the general formula for this, so if we try to differentiate x1 with x2, x3 and x4, so this gradient of fx1, this value is, if we differentiate with x1, this is x1 plus 10 times x2 plus 40 x1 minus x4 to the power 3. If we differentiate it with x2, this becomes 20 x1 plus 10 x2. This is 10 x2 plus 4 x2 minus 2 x3 cube. If we differentiate it with respect to x3, this becomes 10 x3 minus x4 minus 8 x2 minus 2 x3 cube. If differentiate with respect to x4, this is x3 minus x4 minus 40 x1 minus x4 cube. Okay, so this is your gradient of this thing. Okay, and then what is the Hessian? If we here try to find what is the Hessian matrix. Okay, so what is the Hessian matrix? So if this is your f1, f2, f3 and f4, this is del f1 over f1, this del f12, f13, f14, f21 and so on. So if we differentiate f1 with respect to x1, so this becomes 2 plus 120 x1 minus x4 square. This is 20, this is 0, this is minus 120 x1 minus x4 square. Okay. So you have to check that this is correct or not, and you know that how to find these values here. So this becomes 20 plus 12 x2 minus 2x3 square minus 24 x2 minus 2x3 square, and this is 0. Third column is 0. This is minus 24 x2 minus 2x3 square and this is 10 plus 48 x2 minus 2x3 square, and this is, okay, so this one is 0 or 10. Okay, so now you find out what is the Hessian matrix. Okay, so this is your Hessian matrix. So now in iteration 1, so first of all you have to find the gradient and then Hessian matrix. Okay, so now in iteration 1, for iteration first we have to find G0, that is the gradient at x0. Okay, and now if we, this is your gradient x, and x0 point is this thing, you have putting that value, you get this gradient is 306,144 point minus 2 minus 310. So once you check that this is correct or not. Okay, then you have to find the Hessian matrix. Okay, so this is your Hessian matrix, and now this is 4 cross 4 matrix because this is 4 cross 4, and here we write some entries and some are left. Okay, for you can calculate that and try to correct that and fill the remaining entries here. Okay, so and then putting the what is the value of x1, x2, x3, x4. So this is the Hessian of that, and that value is okay. So in this case, this is very complex numerical. So if this numerical is very simple, then no problem. You can putting and then solve at your simple calculation by your own. Okay, but in this form, these points are very complicated. Then you go through the software and try to put there the matrix, and then putting that what is the matrix and what is the inverse of that. Okay, because the entries are here in point. Okay, so this point 1 minus 1.26. That's why we write the first iteration, and you try to solve this problem by your own. So this becomes 0.1106. Okay, so this is simple algorithm. ये आपको एक प्रोसेस बता दी जा रही, आप इस तरह से आप सॉल्व करेंगे. ओके, स्टेप्स आपको क्लियर हैं. इसमें हमने इस फंक्शन की वैल्यू x1 x2 की वैल्यू पुट कर ली और इसको सॉल्व कर लिया, तो दैट इक्वल्स टू 0.008 and here 0.0203 and 0.0155. Okay, so Newton method is better than your steepest descent method, but drawback is that thing, if this problem is in very complex form, this means if there are the function of suppose more than 3 variables, means 3, 4, 5, 6, in that case your Hessian matrix of order that 4 cross 4, 5 cross 5 and so on. Okay, in that sense you are quite difficult to find what is the inverse of that 5 cross 5 matrix or 6 cross 6 matrix. Okay, so if you have a software, then no problem. Okay, then you can solve easily, but in manually this is quite different, because if in this matrix, if you have to find the what is the inverse of that. Okay, so very complicated form. So this is basically inverse of that. Okay, this is inverse matrix, and what is the this G0, and what is the functional value at x0. If you put in that value, this value is equals to here 482, and this is a 1t. This is 482 1t 0 minus 480. If you put in that value, and this is 20 212 minus 24 and 0, and 0 minus 24 58, this is 24 58 minus 10 and minus 480, 0 minus 10 and 490. Okay, so this is the Hessian matrix at point x naught. If you put in that, and then the inverse of that matrix is equals to this thing. Okay, so what is the value of f at x0 inverse this matrix multiplied by this G0 matrix, this into this. Okay, so this matrix into G0, this into G0. If we multiply that matrix, this equals to 1.41 0.27, and second entry is 0.8413, then 0 minus 0.2540, and here 0.7460 transpose. Okay, so then your what is the point x1 here? So the point x1 by the formula of Newton's method, that x1 is x0 minus this inverse of this Gaussian matrix multiplied by gradient, which is g0. Okay, so this is x0. X0 is given here, and this product is you calculated here. So if this minus this, so these values are equals to that x1 point is 1.5873. Second point is 0.587. Third point is equals to 0.2540, and fourth point is 0.2540. Okay, so this is your x1 point. This is your x1 point. Then if we are able to find the then x1 point, then we have to find what is the value at x1. So at that point, we have find the functional value at point x1. Okay, so if we putting here this x1, x2, x3, x2, this point x1, x2, x3 in this function, we get this value is equals to 31.8 here. ओके, तो आप ये देखें कि पहला जो स्टार्टिंग पॉइंट दिया था वो 215 था, 215, और हम फर्स्ट इटरेशन में ही हम आ गए 13.8. ओके, एंड देन नेक्स्ट इटरेशन में हमें क्या करना होगा? वी हैव टू कैलकुलेट this gradient of fx1. Okay, then Hessian of this fx1. Okay, that point, and then inverse of that, then try to multiply that both terms, and then you subtract it from this x1 point, minus of this gradient at x1 point and Hessian matrix at x1 point, then you find your x2 point. Okay, and then in next iteration you have to calculate your x3 point. Okay, तो सिमिलर प्रोसेस आपको करना है, और सिमिलर प्रोसेस करके आप सॉल्व कर सकते हैं, या अगर 2 मिनट अगर आपके पास समय हो तो हम क्विकली इटरेशन 2 3 हम लिख दें. ओके, तो इन नेक्स्ट पेज iteration 2. So here g1, that is gradient of function at point 1, and that equals to, this value is 94.81 minus 1.179 and 2.371 and minus 94.81. Okay, so this is your g1. And what is the Hessian at point x1? If you're putting that value, it is equals to 215.3. This is 20, 0, and minus 213.3. And second column is 20, 205 minus 3, minus 10.67 and 0. And then 0 minus 10.67. 31.34 minus 10, and here minus 2 with 13.3, and this is 0 minus 10 to 3.3. Okay, so here you look at your matrix is will symmetric one, because this 20 20 0 0. Okay, so this is your symmetric values. Okay, and then what is the value of this fx1 inverse? Okay, so that inverse value is equals to, or we directly write the product of that. Okay, so you find the inverse matrix, and then f of x1 inverse with g1. Okay, so this value is, after calculating, if you check that, this is 9.1, this is 0.0529, 0.0846, 0.0846. Okay, so you point x2, this x2 point, is equals to x1 minus the Hessian at that previous point with inverse with g1 that equals to 1.0582 1058 0.1694 and 1694 transpose. Okay, so this is your value, and you have to find what is the value at x2. So this value equals to 6.28. So this is in second iteration. You find the function value 6.28. Now go for last iteration, that is iteration third. Okay, so in iteration third, what is the value of g2? So g2 value is 2809 minus 3475 7031 minus 2808 transpose, and here what is the value of ACN at that point? It is equals to, okay, so you have to calculate that value. That value is 96.80 96.80 20 minus 94.80, this is 2202.4 minus 4.744 0, this is 0 minus 4.744, this is 19.49, this is minus 10, this is 94.80 0 minus 10 and 104.80. So this is your Hessian matrix. Okay, and then if we try to find what is the product of that, and finally you find what is the point of x3. X3 point is 0.7037 0.0704 0.1121 and 111 transpose. Okay, and what is the function value at this point? This point function value is 1.24. Okay, so here you will do the next iteration and then you find the value of that. Okay, तो आज के लिए इतना ही करते हैं, थोड़ा ज़्यादा हो गया. ओके, और ये सारी कैलकुलेशंस जो हैं वो आप कॉम्प्लेक्स न्यूमेरिकल है इसलिए आप सॉफ्टवेयर यूज कर लें. अदरवाइज अगर सिंपल प्रॉब्लम है तो कोई प्रॉब्लम ही नहीं है. 2+2 की मैट्रिक्स हो, सिंपल फंक्शन हो, तो आप आसानी से उसकी ग्रेडियंट निकाल सकते हैं, एसएन निकाल सकते हैं, इनवर्स निकाल सकते हैं और कर सकते हैं सारी चीज़ें. पर यहाँ पे थोड़ा मुश्किल है क्योंकि न्यूमेरिकल काफ़ी टफ है. तो आज के लिए इतना ही करते हैं, आज इतना ही. ओके, और कल हम नेक्स्ट मेथड पढ़ेंगे, दैट इज कंजुगेट डायरेक्शन मेथड, एंड दैट मेथड इज बेसिकली बेहतर है आपके क्या कहते हैं स्टीपेस्ट डिसेंट से, बट न्यूटन्स मेथड से उतना अच्छा नहीं है, उतनी जल्दी रिजल्ट एक्यूरेट नहीं देता. तो लेकिन उसमें प्लस पॉइंट ये है कि हमें अगर हमारे फंक्शन अगर बहुत ही कॉम्प्लेक्स फॉर्म के हो तो हमारे मैट्रिक्स इन्वर्जन का जो इसमें न्यूटन्स मेथड में थोड़ी सी प्रॉब्लम आ रही है. तो कॉन्जुगेट डायरेक्शन मेथड इन दैट सेंस इज बेटर देन न्यूटन्स मेथड. ओके, बट अगर आप देखना चाहेंगे कम इटरेशंस में एग्जैक्ट रिजल्ट्स किस में आते हैं तो न्यूटन्स मेथड में ही आएंगे. कॉन्जुगेट डायरेक्शन मेथड्स में रिजल्ट हमारे उतने एक्यूरेट नहीं आते, बट हमारा जो प्रोसेस है करने का उतना लेंदी नहीं है. अगर हमारे पास जो प्रॉब्लम जो है वो काफ़ी सपोज मोर वेरिएबल्स की प्रॉब्लम है, उसमें अगर सपोज हमारे 20 वेरिएबल्स हैं, उस केस में 20x20 मैट्रिक्स का हमें करना बड़ा मुश्किल हो जाएगा. उस केस में थोड़ा सा इजी है कॉन्जुगेट मेथड. कॉन्जुगेट डायरेक्शन मेथड भी ऑफकोर्स थोड़ा मुश्किल तो है, लेकिन उस सेंस में आपके न्यूटन्स मेथड से बेटर है. बट ऑफकोर्स ये दोनों मेथड, कॉन्जुगेट डायरेक्शन मेथड एंड न्यूटन्स मेथड, बोथ आर वेरी बेटर देन आपके स्टीपेस्ट डिसेंट मेथड. और स्टीपेस्ट डिसेंट मेथड आपके ग्रेडियंट मेथड से. ओके, तो अगर आप रैंकिंग करें तो ग्रेडियंट, देन स्टीपेस्ट डिसेंट, देन कॉन्जुगेट डायरेक्शन एंड देन न्यूटन मेथड. ओके, फॉर एक्यूरेसी ऑफ रिजल्ट. But for calculation wise and for complicated form of the function and the number of variables are more, then in that case conjugate direction method is quite better than this Newton method. ओके ओके, तो आज के लिए इतना ही करते हैं, फिर नेक्स्ट